Hello class and welcome to this week of CIS 112 Operating Systems Beginning Linux. This week we'll be looking at package managers, packages, and managing backups in Linux. So all essential skills. So you'll learn how to use package managers to install, update, and remove software. So just like you install software on your Windows or Mac computer or maybe Chromebooks, we do the same thing in Linux through package managers. So applications, their files, everything we need to run a specific software, we call those packages. And if we're going to install those very quickly, especially through command line, we're going to be using package managers. So explore methods for creating and restoring system backups, which are crucial for protecting data, ensuring quick recovery from data loss. So one essential skill is saving all your data, right? All your files on your Linux system in case of, a critical failure. So if you want to back up those files, just like you back up your photos, right, to iCloud, there are mechanisms so that you can back up your Linux system and save it for future use. Maybe you just want to back up the system in case you want to go back to a previous version of the system. As a bonus, also be going over snapshots with virtual machines, similar to system backups, but slightly different. But they do offer the same functionality in the sense of going back to an older version and then also keeping and saving your data in case of critical failure. So we'll learn how to manage software packages efficiently, and we'll even install a software package that helps us with system backups. So the point of installing extra software right onto your computer is to help you more easily solve some tasks. So a little bit of review. Remember, sudo is the group that has elevated privileges in Linux. It shares some of those privileges with root user. You can definitely control how much of those privileges sudo will have. Sudo is definitely better than root because it's kind of like you're wearing gloves, right? Before you're actually messing with the system. Whereas with root, right, you're kind of just you're going bare metal, to say the least, where you're not being logged by the security system. You have full control of the system, and that can lead to unintended consequences, right? You might accidentally do something to the system that might have it crash or might delete important files. So sudo is a little bit better because it does have that security logging and it does have that controlled access because we can decide who's sudo. Once you give somebody the root password, it's kind of the system is theirs. All right, so packages. So this is the first concept we'll be covering in this week. So package is the collection of files and metadata required for software to function correctly on a Linux system. So just like when you install a new program, you go through that installation process, some files are set up. The same idea applies for Linux system. So think of a package as a neatly packed box that contains everything you need to set up an application. So literally a package, right? So it's a package of all the things you need to run a tool, a software, an application. So for example, the Git package includes all the program files, libraries, and documentation for the Git version control tool. So Git's very popular. Um, File version control system when you're creating new software. Or maybe you just want to save some files that are constantly updated. Git is definitely an industry standard. But this class is not about Git, right? It's just about Linux. So Git is an example of a package. We'll be installing one package in our demo that is for system backup. So we're going to kind of combine the two concepts together. So if we're going to back up our system, maybe it's useful, right, if we install a tool that makes it easier to do that. And some of these tools even have GUIs, so not everything has to be through command line. So the purpose of installing packages on a Linux system is to add software or tools that extend the system's functionality. When you get your first laptop, right, it doesn't have that many programs on it. It really becomes useful once you start to install all the software that you use day to day. Same with the Linux system, right? When you start with that base Linux operating system image, maybe it doesn't have too much to work with, but as you install packages that are useful for your day to day workflow, then instantly, right, that Linux operating system becomes way more useful. So here are some popular Linux packages. So there are text editors, so Vim and Nano. Some of these are already pre-installed, as we can see in Ubuntu, right? If you run Nano command, you'll be able to edit certain files. In other Linux systems, the really bare bone ones, you actually have to install Nano. Git, like I mentioned before, is a version control system for tracking changes in code. There's GCC, there's Node.js and NPM. I actually use NPM on my day-to-day software development for my coding. So that's a very, very popular package manager if you're working with Node and JavaScript. So it's widely used for web development, which is my primary role. Then we have network tools. So curl command, so that's for transferring data from URLs. So instead of, downloading a picture by going through Google Images and so forth, you can just run a curl command and copy the URL of the image and it'll download it for you. A wget is another one of those utilities for downloading files, very similar to curl. We also have system monitoring utilities, htop, tmux, ncdu, some that I've never used before. Docker, if you're working with containers and you want to run applications as containers, Docker is a very industry standard one. So it's basically putting whole applications as images, as Docker images. So it's very easy to run them. VirtualBox has its own command line package that you can use. rsync, which we'll be using today. tar as well we'll be using today. So that's for backing up and syncing files. So again, a lot of these are already pre-installed to your Ubuntu. Of course, we'll be installing some extra ones today. So package management is the system that automates the installation, updating, and removal of software. So in order to download these packages, you need a package manager. So for example, if you're coding in Java, the package manager in Java is popularly known as Gradle. We already mentioned with Node, JavaScript, right? If you're a JavaScript coder, the package manager you use is NPM, Node Package Manager. If you're on a Linux operating system and you're in a Debian or Ubuntu distributions, notice there's different, right? There's Fedora. We already explored in the first week how there's many flavors of Linux, but if your flavor is Debian or Ubuntu, the package manager by default is apt, or sometimes called apt, right, for short. So this is what allows us to install packages to the entire system. So apt stands for Advanced Package Tool. It's for Debian and Ubuntu, just like we mentioned. It's widely used for Debian systems. Ubuntu is not the only Debian system, but it provides commands like apt-get for installing, updating, and removing packages. So for example, if you wanted to install a package, you'd do sudo apt install package name. The reason we need sudo, right, is because you're installing them to the entire system. If you were on a different Linux distribution, such as Fedora or CentOS, you'd be using yum or DNF. So these are different package managers. We're not going to use them for our particular VMs since we're all running Ubuntu. Homebrew, another one that works for Mac and Linux. I've used Homebrew to install certain software on my virtual machines. When I tried to install it other ways, sometimes it's too many steps, too difficult. When you use a package manager like Homebrew, it makes the installation process really easy. It does a lot of the steps for you. Pip is a massively popular package manager. It's primarily for Python environments. So it is a package manager for Python that allows the installation of libraries and tools from the Python package index, or commonly known as PyPy. It's essential for managing Python dependencies. So if you're coding in Python, you can run a pip install to download a package. Maybe you're doing machine learning, right? Maybe you're doing computer vision. Maybe you're coding some kind of AI tool, right? You're definitely going to want to pip install some packages to help you do that specific type of coding. We'll explore that. Pip install, you can also use it to install user level packages. We'll discuss that in a sec. NPM, we already mentioned, is for Node. And of course, when you install a package, another key concept is dependencies. So packages nowadays, they work by communicating or integrating with other packages. So rather than, let's say you wanted to build your own package, right? Maybe you want to do your own version of Git, of the source control tool. You might use Git as a dependency, and then you might add another tool as another dependency. You combine the two tools together, you add your own customizations, and boom, you have a new tool. Your tool has a dependency though on those other tools that you use to build your current tool. So we'll kind of paint it a little bit better with this picture. So say you have an app, right? And your app runs on these two packages. So these two packages are dependencies for your app. In the example of my software development, so when I'm coding a new website, I'll often use packages that allow me to more quickly create, for example, buttons or JavaScript code. So whenever I use a package like that for my coding, my application now has a dependency. It depends on that tool for my software to run. So yeah, when your app has packages that it depends on, we call those dependencies. And these packages might depend on other packages. So in this example, right, we see the green pictures here. So even those packages have dependencies. In fact, a lot of packages today, you can draw a really complicated tree of dependencies because developers nowadays, right, they don't start from scratch. They'll start from a pre-existing package, modify it, and then make their own package. So at the end of the day, most packages have dependencies. The advantage of package managers is they'll actually automatically check and install dependencies to prevent any issues. Because, like I said, most packages depend on other packages. The package managers will manage that automatically when you hit, sudo apt install. It'll download everything you need, including dependencies. So yeah, it's basically when software relies on another piece of code or library, you call it package, to perform a specific function. They support applications by providing necessary functionality rather than reinventing the wheel. Right, you can just include a package as a dependency in order to solve a new problem. So for example, the curl package does have a dependency on libssl in order to handle secure connections whenever that URL has a security protocol to it. All right, so let's go ahead and move on to a video. So I found another cool video from this YouTube creator, and he goes over package managers. So I think it's very useful to watch. He goes very in depth. All of his videos are from the perspective of a hacker, right? Linux is typically used to run servers. But yeah, it's still very useful. He goes through a lot of detail. So definitely invite y'all to watch it. Don't have to watch the whole thing, but definitely watch at least the first few sections where he explains package managers. But yeah, essentially, right, package managers, a package is a program, a tool. Package managers allow you to install those programs and tools. All right, go ahead and click onto that next video and we'll start up the lesson after that one in the playlist.